You may recall that last week's tutorial went over why I use PNG file formats instead of JPEGs. In this video, I will explain in more technical detail the difference between JPEGs and PNGs and why simply thinking it is about alpha transparency is only scratching the surface. PNGs, short for Portable Network Graphics. I would first like to start at the PNG file format compression method. Which refers to the fact are entirely lossless, that the file attempts to store the data as accurately as possible without altering it in any way. PNGs filter each channel separately on each row using a process known as delta encoding, which, if you are familiar with delta from physics or calculus classes, you may be able to guess, represents the difference in values between two adjacent pixels. This becomes handy because if each pixel value on a row has the same difference between each one, then you can store the difference, which will be a constant value, as opposed to the unique value that each pixel has on its own. The filtering can also apply up and down difference rather than the left and right described earlier. Take the average of the left and right and the up and down, or use a linear function that uses the left and right differences, the up and down differences, and the difference between the original point and the point to the upper left of it as the inputs, creating a 2x2 square. The algorithm determines which filtering method is best by taking the absolute value for all the pixels on a row, and then adding all these values in a row together after the filter is applied, and then reiterating this process for all the other filters until it finds the one that provides the smallest sum possible. One important caveat to this is that the more columns or rows of pixels there are in an image, the more differently the scan results will be each row. Even if you have a very slight difference, i.e. only 2 extra columns of pixels, the file size can be much larger, such as twice or 3 times the original file size. This is because, even with only a slight change, the difference in how the pixels are spaced apart is treated greater by the compression method. So pixels that would normally be grouped together and compressed are now too far apart according to the compressor. One last thing to know about PNGs is that the pixels you see on screen and the compression method I just described is only a small part of the overall data the PNG file uses. This is because PNGs use what's referred to as metadata, or information about the file, for the reader's convenience. Examples of metadata include the width and height information, the date modified and saved, and the end of file. However, you can export the PNG to web, which will erase all the metadata for you and make the file size much smaller. Now that we have gone over the PNG file size and compression, we may now go over how to actually save the PNG images. In Photoshop, you simply click File, and then Save As, and then PNG. However, in GIMP, you click File, and then Export As, like so. And then you will manually have to type in dot and then the file extension, in this case PNG. After that, click Export. On the Export menu, you may notice an option known as Interlacing. This allows you to save a low-quality version of the image for faster loading times on the web. However, this adds more data to the image overall, and so I do not recommend it. On GIMP, you will notice there are options that Photoshop does not, such as the ability to save the background color, the ability to save gamma, or the ability to save the color values in transparent pixels. This is because GIMP does not have an export for web feature, and so it makes up for this by allowing you to save individual parts of the metadata. On both GIMP and Photoshop, there is also an option to save the compression level, with 1 being the least compressed and 9 being the most. Because of the way PNG compression works, even if you have it at the maximum setting, you should not be able to see any clear difference in your file. There are also options on both GIMP and Photoshop to save the image as either 8-bit or 16 bits per channel, and as either grayscale or full color. There is also an option whether to include the alpha channel or not. Options that allow you to include the alpha channel have the A at the end of the word. Now that we have gone over how PNGs work, we are able to discuss how JPEGs work. While PNGs are a good introduction to compression, JPEGs have a more sophisticated compression method and are more commonly used. This is because JPEGs are used for photos, as JPEG actually stands for Joint Photographic Experts Group, the name of the company that developed the file format. While PNG compression is known as lossless, JPEG compression is known as lossy for the opposite reason. It discards a lot of data to make the file size much smaller. JPEG compression works by utilizing the principle that the human eye is more sensitive to changes in light than it is to in color. JPEG first converts each pixel from RGB to YCBCR, where Y is the brightness or luminance value. Although the Y channel is the most important for JPEG, CB refers to the blue difference, and CR refers to the red difference, which it will also filter. Samples the Y value of every individual pixel. This means that the brightness is now isolated to a single channel and is much more easier to detect. With that out of the way, we're able to go into more technical detail of how exactly JPEG compression works. For example, a compression of 1 would do 2 by 2 blocks, whereas a compression of 2 would do 4 by 4 blocks, a compression of 3 would do 8 by 8 blocks, and so on. Each group is then compared. Note that the compression level of your JPEG image and then sample CB and CR in a 2 by 2 block instead of each individual pixel like Y. And the bottom right being the most changes in light along both the Y and X axes for a checkerboard look. Will become the most compressed, with the top left being no changes in light whatsoever. This table is checked from the top left to the bottom right to a table of changes in light in that group. Exporting JPEGs works just about the same as exporting PNGs. The difference in GIMP is that the sections in the image with the greatest change in light, whereas the images with no changes in light will be the least compressed. The only difference being that in Photoshop you're allowed to select how it loads and are given more levels of compression versus a PNG. You will be given compression levels from 0 to 100, meaning quality percentage, with 100 being minimal compression and 1 being most compression. You're also not allowed to choose whether to save a JPEG's metadata in GIMP, whereas you could with PNG. However, in Photoshop, you can still optimize both images for web using the checkbox. It is also important to note that for either image format, you are not able to reverse the compression once you save it. So it is important to be mindful about the exact number you use for your compression so that you don't make the image too blurry. There exist many other file formats besides PNG and JPEG. Which you may encounter in some games you download off the web. But I will not be doing that until much later because we still need to learn more tools before we can animate GIFs. But we will not be discussing these file formats because they are not as widely supported across multiple operating systems and apps the way PNGs and JPEGs are. However, we will be discussing the GIF file format in a later tutorial. In next week's tutorial, we will be learning about the different drawing and select tools. Don't forget to subscribe if you found this video informative, and make sure to visit the other tutorial videos and follow me on either Facebook or Twitter for more content.